To solve this system of equations, I'm going to use the method substitution. And the reason I'm going to use substitution is because at least one variable is isolated. In this case, two variables are isolated, the y and the y in both equations, okay? So I'm going to substitute this y with the 2x plus 9, okay? Because 2x plus 9 equals y. So I'm going to take out this y, and I'm going to put 2x plus 9 in its place. Okay, so now I'm going to solve for x. Okay, so now I know that x equals 6, and now I need to solve for y. If you can recall, here are the original equations. So I just need to pick one. I'm going to pick the top one, and I'm going to substitute x for 6. And now I solve for y. So now I know that these two equations will meet at the point 6, 21. Okay, we have another system here which calls for substitution because one of the variables is isolated. Even though no variable is isolated here, it's okay. We're going to work with this, okay? So y equals 2x minus 5. And y is also over here. So I'm going to substitute 2x minus 5 into this y. And this is the equation that I want to work with to solve for x. So I'm going to distribute the 4. So 4 times 2x is positive 8x, and 4 times negative 5 is negative 20. Okay, now I'm going to write everything else the way it is. And now I'm going to solve for x. Now I know that x equals 1. If you can recall the original equations, I'm going to use the top equation, y equals 2x minus 5, to solve for y. I'm going to substitute x for 1, and now I'm going to solve for y. So now we know the two lines are going to meet where x is 1 and y is negative 3.